Example 3 is 8x squared minus x minus 9. Okay, first look for a greatest common factor, which there's not one, and then make sure your problem's in the correct order, in descending order, which it is. Okay, so that means we're going to multiply the first coefficient times the last. So 8 times negative 9 would be negative 72. Make a list of the factors of 72, and I would start with 1, especially if it's a larger number. 1 times the number, 2 will go into 72 36 times, 3 will go into 72 24 times, 4 will go into 72 18 times, 5 will not divide into it evenly, 6 times 12, 8 or not 7 will not divide into it, but 8 times 9. Okay, you may not need to make the complete list. Once you find the two numbers that work, you can stop. Okay, so now let's look at to see what we're looking for. If it's a negative number, if it's a negative 72, okay, that sign is going to tell you you want the two numbers that will subtract to give you the middle term. Okay, if it's a negative number, you want what two numbers will subtract, in this case, to give me negative 1. Okay, so that's an understood negative 1. So I would use 8 times 9. Okay, how do I decide which one is negative and which one is positive? Well, I need it to subtract to give me a negative 1x. Okay, that means the higher number, the 9 would have to be negative, the 8 will be positive. So I attach x to both of those. Those are the two numbers I use, so I would have 8x and negative 9x to get the signs correct. Divide each one by the first term, which is 8x squared, and then reduce. Okay, when I reduce 8x over 8x squared, 8 would go into 8 one time, so that will leave me with 1, but x over x squared leaves me with x, so that reduces to 1 over x. Negative 9 over 9x over 8x squared, well, the negative 9 over 8 will not reduce, but x over x squared would leave me 1x in the denominator, and that should be what's going to happen every time. Your x is going to end up in the denominator. Now we say bottoms up or bottom to top. My solution would be x plus 1 times 8x minus 9. So if I write those two binomials, if we multiplied those, it would equal back to the problem we started with. Now, it doesn't matter as far as the order. If I wrote this as 8x minus 9 times x plus 1, the order of the two binomials does not matter, because if you multiply them together, it's still going to equal back to the original problem. Okay, example 4. You have 8x squared plus x minus 7. Okay, so again, there's not a common factor and the problem's in the correct order. 8 times negative 7 equals negative 56. And so I'm looking for the two numbers that would add or that would subtract because it's negative. That means we want the two numbers that will subtract to equal a positive 1x. Okay, if we need to make a list, we start with 1 times 56. That's not going to subtract to be 1. 2 will go into 56 28 times. That's not going to subtract to be 1. 3 will not divide into it. 4 will go into 56 14 times. That's not going to subtract to be 1. 5 will not divide, 6 will not divide, 7 will divide 8 times. If I subtract 7 and 8, that is going to give me positive 1. Okay, but then you need to figure out which one needs to be negative, which one needs to be positive. So it's always the higher number will take this sign that's in the middle of your for your middle term. Okay, so that means the 8 needs to be positive, the 7 needs to be negative. So those are the two numbers we use. So I would write negative 7x, positive 8x. Always attach this variable in the middle to those two numbers. Divide by the first term in my problem. So I divide by 8x squared and then reduce. Okay, if I reduce, negative 7 over 8 will not reduce, but x over x squared leaves me x in the denominator. 8x over 8x squared, we would say 8 will go into 8 one time, so I have a 1 in the numerator. X over x squared is x. Okay, bottoms up, to write my two polynomials or my two binomials would be 8x minus 7 times x plus 1. So if we multiply these back together using the FOIL method, that's how you can check it, it should equal back to the original problem that you started with. Okay, let's look at number 5. 14x squared plus 4x minus 10. Okay, remember I said first thing we should look for would be a greatest common factor. Okay, if I look at all of my terms, 2 will go into all of them. So before I do anything else, I'm going to factor out a 2. 2 will go into 14, with leaving you with 7x squared. 2 into 4x would be a positive 2x. 2 into negative 10 would be negative 5. Okay, so we take the common factor out first, then follow the same steps with the trinomial that's in parentheses. So again, it's in the correct order. 7 times negative 5 would be negative 35. Make a list of the factors. 1 times 35 and 5 times 7. So what's going to subtract to be 2? Okay, well, 5 and 7. The higher number taking the middle sign here, so that means the 7 is positive, the 5 is negative, and I attach that middle variable, the x. So I would have a negative 5x, a positive 7x, divide by the first term, okay, which is the 7x squared, reduce, negative 5 over 7 is not going to reduce. X over x squared leaves me with x in the denominator. 7 into 7 one time. X over x squared leaves me with x. So bottoms up, write the two binomials. 7x minus 5 times x plus 1. If I multiply this back together, it would not equal my original problem up here. And it's because of this 2. Okay, if you take out a common factor, you must include it with your answer. Okay, if you don't include it with the answer, it's not going to be correct. All of this multiplied together would equal back to my original problem. Okay, so if you take out a GCF, make sure you include it with part of your answer for your question.